Once a symbol of the ocean's raw power and nearly hunted to extinction, whales today stand at a fragile crossroads, a traditional source of food, or a species that must be absolutely protected. In Japan, around 200–300 minke whales are harvested each year within the nation's exclusive economic zone, sustaining a marine industry that has existed for generations. Amid freezing waters and powerful waves, seasoned sailors confront creatures weighing nearly 10 tons, working in precise coordination to bring the whales onto the deck and begin processing them right there at sea. The meat is then sorted, trimmed, and preserved under strict standards before making its way to seafood markets and traditional restaurants. Today, with Agriculture Insight, we will follow this entire journey from the depths of the ocean to the dining table, to explore how one of the largest animals on Earth becomes part of a modern food supply chain. Now, let's step into the world of Japanese whales and uncover fascinating, little-known facts before exploring the massive hunting operations and processing chain behind these ocean giants. The minke whale is a small baleen whale, measuring about 7 to 10 meters in length and weighing up to nearly 10 tons. It can reach speeds of over 30 kilometers per hour when accelerating. With an average lifespan of around 50 years, minke whales grow slowly, and females typically give birth to only one calf after nearly a year of pregnancy, a trait that makes resource management particularly sensitive. After World War II, whale meat once accounted for nearly 50% of Japan's total meat consumption during a time of severe food shortages. However, as the economy recovered and food options diversified, consumption declined sharply and now represents only about 0.1% of the nation's total meat intake. Even so, Japan continues to harvest approximately 200 to 300 minke whales each year within its exclusive economic zone, maintaining that the practice is legal and regulated. Minke whale meat has a distinctive dark red color due to its high myoglobin content, even deeper in tone than beef. The texture is firm, fine-grained, and relatively lean. When eaten raw, it has a mild sweetness with a subtle hint of the sea. When grilled, its flavor is often described as a blend between beef and tuna. It is rich in protein, iron, and omega-3 fatty acids, but because it may contain mercury, consumption is generally recommended in moderation. Whaling in Japan has become the center of one of the most prolonged and divisive debates in the modern world. The so-called whale war intensified when Japan withdrew from the International Whaling Commission, which had imposed a commercial whaling moratorium in 1986. Conservation groups such as Sea Shepherd Conservation Society have repeatedly confronted whaling vessels at sea, turning the issue into a global media flashpoint. Today, the story of Japanese whaling is no longer just about food. It represents the intersection of tradition, science, economics, and conservation, where a nearly 10-ton marine giant has become a symbol of how humanity chooses to exploit or protect nature in the 21st century. Whale reproduction is a slow yet highly strategic cycle, unfolding across the vast ocean. In species such as the minke whale, the breeding season typically occurs in winter, from around December to March, when they leave cold, food-rich waters and migrate toward warmer seas. Male whales produce sequences of low-frequency sounds that can travel for dozens of kilometers underwater. The more stable, rhythmic, and sustained the calls, the stronger the signal of health and vitality, essentially a biological resume transmitted through the sea. After fertilization, the female carries her calf for about 10 to 11 months. Calving usually takes place in late winter or early spring, in warm, calmer waters where survival rates are higher. Almost always, a single calf is born, measuring about 2 to 3 meters in length and weighing close to a ton. During the first 6 months, the calf feeds on its mother's rich, high-fat milk, growing rapidly in preparation for its first migration. Throughout this time, the mother remains close, teaching her calf how to surface for air, how to dive, and how to adapt to the rhythms of the ocean. A slow but deliberate investment characteristic of one of the ocean's most powerful marine mammals. Japan's hunting of the minke whale today primarily takes place within its 200 nautical mile exclusive economic zone, offshore from areas such as Hokkaido, the Sanriku coast, and parts of the Sea of Japan. The season typically begins in late spring and extends into early autumn when sea conditions are more stable and whales move along established feeding routes. Each whaling vessel usually carries around 15 to 25 crew members, including a captain, navigators, engineers, and a specialized harpoon team. The primary tool is a bow-mounted harpoon cannon fitted with an explosive tip, a technology refined over more than a century to improve accuracy and shorten the time needed to secure the animal. The strategy does not rely on high-speed pursuit, but rather on tracking migration patterns and carefully observing the whale's surfacing behavior. Once a target is identified, the vessel approaches from behind or at an angle to maintain a steady firing position, timing the shot to the brief moment the whale surfaces to breathe, often lasting only a few seconds. All operations are conducted under annual quotas and require detailed catch reporting at the end of each season. Across thousands of square kilometers of open sea, the hunt represents a fusion of traditional seafaring knowledge and modern mechanical precision, a practice defined more by calculation than by force. When a minke whale is fully secured on deck, the clock essentially starts ticking. In the first few minutes, a processing team, often around 20 crew members, must stabilize the nearly 10-meter-long body using steel hooks, chains, and hydraulic winches to prevent it from shifting as the vessel continues to roll with the waves. The first step is opening the abdominal cavity. Specialized knives with blades measuring 40 to 60 centimeters are used to make a precise incision along the belly. Once the cavity is opened, internal pressure is released, making the next stages safer. The organs are removed in sequence. The stomach and intestines first to reduce weight, followed by the heart, liver, and lungs. The stomach alone can weigh up to 300 kilograms, depending on its contents. Next comes the removal of the blubber, a thick layer of fat averaging 10 to 20 centimeters, covering the body like a biological shield. The fat is cut in long parallel strips, then lifted in massive sections weighing hundreds of kilograms using steel hooks and winches. In the 19th century, blubber was rendered into industrial oil. Today, it is primarily used for culinary purposes or oil extraction. Once the blubber is removed, the deep red muscle beneath becomes visible. The long back muscles, considered the most valuable, are separated into large sections. Industrial saws are used to detach ribs and vertebrae. The meat is then rinsed with clean seawater and transferred immediately into cold storage maintained at 0 to 4 degrees Celsius. The fins and tail are processed last. The tail, which generates the whale's propulsion, contains especially dense and powerful muscle fibers, making it structurally tougher than the rest of the body. The entire procedure typically takes 3 to 4 hours, depending on sea conditions. Every movement follows a fixed sequence, coordinated precisely between people and machinery, a massive processing operation carried out at sea, where even minutes of delay can affect the final product's quality. Once properly chilled, the meat moves to the portioning and packaging stage. Large mussel blocks are cut into standardized commercial portions, typically weighing 2 to 5 kilograms, or sliced thinner depending on market demand. Each piece is inspected for color, texture, and core temperature before being vacuum sealed to minimize oxidation and preserve quality. The packages are then labeled with processing dates and harvest location details. Finally, the products are stored in deep freeze facilities at approximately 20 degrees to 30 degrees Celsius, ready for distribution to seafood markets, restaurants, or further processing centers. Now, have a napkin ready because you might start craving it once you see how minke whale is transformed into sushi. Minke whale meat is typically divided into 3 main cuts. The back loin, deep red, lean, and fine-grained, considered the most premium. The belly, lightly marbled and softer with a richer mouthfeel. And the section near the tail, where the muscle fibers are thicker and firmer. For sushi, chefs prefer the back loin close to the spine because of its intense, ruby-like color and natural elasticity when sliced. Whale sushi is cut thin, about 3 to 5 millimeters, preserving tenderness while still allowing the structure of the muscle fibers to be felt. Placed over warm vinegared rice, the dark red slice contrasts strikingly with the white grains, minimal yet visually bold. Its flavor is often described as a cross between lean beef and ocean tuna. Rich, slightly sweet, with a subtle marine note but not overly fishy. Many restaurants serve it as traditional nigiri, with just a touch of wasabi and a light dip in soy sauce to avoid overpowering the natural taste. In some places, the surface is briefly seared, aburi, releasing a faint aroma from the thin layer of fat. In Japan, whale meat generally sells for around $15 to $30 per kilogram, depending on the cut and supply. In specialty restaurants, a single piece of whale sushi may cost $4 to $8. Though not widely consumed, those deep red slices on a traditional sushi counter still carry a sense of rarity and boldness, enough to tempt the curious into trying it at least once. But beyond meat and its visible value, there's something few people expect: a quiet treasure of the ocean: whale poop. When whales dive hundreds of meters to feed and then return to the surface to breathe and defecate, they transport iron and nutrients from the deep sea back into sunlit waters. A single large whale can release hundreds of kilograms of waste per day, fueling what scientists call the whale pump. This natural fertilization boosts phytoplankton growth, the microscopic organisms responsible for producing nearly 50% of the oxygen we breathe, while also helping absorb carbon from the atmosphere. Yet there is another, far rarer form of waste, and far more valuable: ambergris. This substance forms almost exclusively inside the digestive system of the sperm whale as it processes squid. After drifting at sea for years, the rough, waxy mass oxidizes under sun and salt water, transforming from a harsh odor into a warm, sweet, complex scent. In the luxury perfume industry, ambergris has been valued at $20,000 to $50,000 per kilogram for its extraordinary ability to fix and extend fragrance longevity for hours, even days. From an unremarkable floating lump to floating gold, it proves that the ocean hides treasures in the most unexpected forms. Many people think grapes should be soft and juicy, but Shine Muscat, a premium peony grape from Okayama, the sunniest and least rainy region in Japan, features a firm, jelly-like crunch and a sweetness reaching 20 degrees Brix, about 1.5 times higher than ordinary grapes. The secret of Japanese farmers lies in calculated sacrifice. From the moment the vines begin to flower, they prune ruthlessly, allowing each branch to retain only a single best grape cluster, forcing the plant to channel all the nutrients, sugars, and essence, originally meant for dozens of other clusters, into one single entity. Not stopping there, they continue to hand-thin each small grape within the cluster, ensuring enough space for the remaining grapes to grow large without being crowded, while allowing air and sunlight to reach every gap. Not only that, each Shine Muscat grape cluster is wrapped in a special paper bag while still on the vine to block insects, harsh UV rays that can scorch the skin, and even rain droplets that may cause mold. This is precisely why Japanese Shine Muscat grapes have smooth, glossy skins that can be eaten directly, without bitterness or chemical residue. When harvest time arrives, instead of cutting in bulk, farmers measure the sugar content of each individual cluster using handheld meters. Only those that meet the standard are allowed to be picked. Each grape cluster is carefully handled and harvested entirely by hand, like a living piece of jewelry. Farmers use specialized scissors to cut each stem with absolute precision, avoiding any movement that could damage the delicate skin. Once picked, every cluster is immediately placed into a cushioned tray to preserve its perfect shape and natural gloss. There is no mass harvesting, no stacking, only meticulous care at every step. With the enormous labor costs involved in meticulous hand cultivation, each premium Shine Muscat grape cluster can fetch $100 to $200 at auctions or in high-end supermarkets. Leaving the mainland behind, seafood has become the second front through which Japan has built a luxury empire worth around $2.5 billion annually, turning the country into one of Asia's leading sanctuaries for high-end seafood. Among more than 400 commercial seafood species, bluefin tuna dominates the premium segment, making it the most sought-after ingredient in the world of sushi and sashimi. The otoro, the fattiest cut from the belly of a top-grade bluefin tuna, can be priced at $30,000 to $50,000, comparable to a luxury sedan such as a Mercedes-Benz E-Class, and sometimes even higher at early-year auctions. Traditionally, bluefin tuna are caught during the winter season, concentrated in the northern Pacific Ocean, using methods such as handline fishing or longline fishing to preserve meat quality. However, in response to rising global demand and the growing risk of depleting natural stocks, offshore bluefin tuna farms have emerged, with Japan being one of the pioneering countries. These kings of the ocean are raised in massive circular cages in deep waters, where currents, oxygen levels, temperature, and feeding regimes are strictly controlled. Automated feeding systems precisely distribute feed, allowing the fish to grow evenly and achieve an ideal fat ratio. Thanks to advanced offshore aquaculture technology, Japan produces more than 10,000 tons of farmed bluefin tuna each year, with an estimated value of at least $700 million, securing the country's position as the world's #1 producer of farmed bluefin tuna in the global luxury seafood segment. At the auction floor, each bluefin tuna is assigned an identification number to precisely trace its origin, weight, and fishing vessel. The fish are then moved into a deep-chilled auction hall, where seasoned traders assess quality solely by meat color, fat marbling, and firmness before placing bids through subtle hand signals. The highest record ever set was a bluefin tuna sold for 333.6 million yen, approximately $3.1 million in Tokyo. Once the auction concludes and the fish belongs to the winning buyer, master tuna cutters immediately begin breaking down the fish the same night, separating each cut with absolute precision to preserve freshness, texture, and maximum value. Leaving behind the heart-pounding auctions at the harbor, we return to land to encounter Japan's culinary national treasure, Wagyu beef, a type of meat known for its painting-like marbling and aristocratic care process. The high price of this beef, especially the top-grade A5, stems from a feeding cycle that lasts twice as long as industrial cattle. It takes at least 30 months to reach full maturity in marbling structure. Throughout this period, the cattle's diet is fully personalized, consisting of a nutrient-rich blend of grains, rice straw, and soybean pulp. Notably, to prevent stress, an element that can toughen meat and reduce fat quality, farmers raise the cattle in an environment of absolute calm. At some traditional Wagyu farms, particularly during summer, farmers give cattle small amounts of beer to stimulate appetite. Alongside this, manual massage is used as a stress reduction method, helping fat distribute more evenly within the muscle fibers. A cow is allowed to leave the farm only when it reaches 700 to 800 kilograms and passes one of the strictest grading systems in the world. Only meat with a perfect fat-to-lean ratio, vivid red color, and glossy texture earns the A5 stamp. Wagyu fat melts at around 25 degrees Celsius, lower than human body temperature, creating the sensation of meat melting on the tongue with a delicate aroma. Each cow has its own birth certificate, with a unique nose print to trace its lineage, and the most expensive cuts, such as ribeye and tenderloin, are served at luxury teppanyaki restaurants or exported to the United States and Europe at prices of $500 to $1,000 per kilogram, making Wagyu a true symbol of Japanese luxury. More than 45,000 hectares of specialized farmland are dedicated exclusively to tea cultivation, concentrated mainly in Japan's midland and mountainous regions such as Shizuoka, Uji, Kyoto, Kagoshima, and Aichi. Despite accounting for only a very small share of the country's total agricultural land, the green tea industry generates hundreds of millions of USD annually for Japan. Rather than pursuing mass production, green tea has risen to become one of the 4 high-value pillars of Japanese agriculture, alongside rice, premium vegetables, and specialty fruits. It has helped Japan maintain its #1 position globally in matcha and firmly assert the prestige of Japanese agricultural products on the world market. The secret behind the vibrant jade green color and the irresistible umami sweetness of Japanese matcha lies in its shade-growing technique. About 3 weeks before harvest, artisans cover entire tea fields with layers of black netting or straw, blocking up to 90% of sunlight. In the darkness, the tea plants are pushed into survival mode, forcing them to produce a massive amount of chlorophyll to absorb the scant remaining light. At the same time, this process drives a sharp increase in amino acid levels, creating the matcha's signature calming effect. The result is a tea leaf with highly concentrated nutrients, an almost mesmerizing green hue, and a smooth, gentle sweetness, something no tea grown under direct sunlight can ever replicate. During the harvest season, typically in early May, the intelligence of Japanese agriculture is clearly demonstrated. To meet the global surge in demand, with more than 2,000 tons of tea exported to the United States each year, specialized tea harvesting machines from popular lines such as Valiant and Ochi have become the key for Japan to optimize production. Operating by enveloping entire rows of tea plants, using curved cutting blades to create a uniform dome shape, and simultaneously employing high-pressure air streams to blow freshly picked leaves directly into collection bags in an instant, each machine can process over 1,000 kilograms of green tea per hour, fast, consistent, and efficient, while still maintaining the quality standards required for industrial processing. Once inside the factory, the tea leaves are immediately steamed to lock in their color and halt the oxidation process. After being air-dried to become tencha, the most delicate step begins, removing the leaf veins. All stems and veins are completely discarded, leaving only the purest part of the leaf. This is precisely why Japanese matcha powder is always silky smooth. Finally, the product is finished using massive granite stone mills. To preserve its highly sensitive flavor, the stones must rotate extremely slowly to prevent heat from altering the aroma. It takes a full hour of continuous grinding to produce just 30 grams of powder, so fine that it seems to melt instantly upon touching the tongue. Despite competing with low-priced matcha, Japan maintains its position through extreme meticulousness. This craftsmanship has pushed the price of premium tencha to $56 per kilogram, while ceremonial-grade matcha can reach hundreds of dollars for just a few dozen grams. Although Asia accounts for 97% of global seaweed production, Each country holds a very different strategic card. China dominates industrial-scale seaweed processing, supplying thickening agents for the additives market, materials that quietly provide smoothness to lipstick, toothpaste, and processed foods. South Korea and Japan, by contrast, are masters of value elevation. They transform seaweed into the soul of sushi and kimbap, driving the price of each dried sheet to dozens of times higher than its raw form. At the opposite end of the spectrum, Indonesia and Northern Europe are pioneering seaweed as a strategic ecological weapon. This power lies in seaweed's whole-body absorption ability. Every surface can absorb nutrients, rather than relying on roots like terrestrial plants. As a result, in regions with dense seaweed growth, excess fertilizer residues and heavy metals in the water can drop dramatically after just a single growth cycle, directly eliminating the causes of oxygen depletion that suffocate fish and shrimp. And now, we arrive at the process everyone has been waiting for. Each year, more than 30,000 tons of dried seaweed are exported from South Korea through high-tech production lines, generating over $700 million in revenue, surpassing even the export value of fresh pears and many other major fruit commodities. In South Korea, the peak of the green gold harvest typically begins in November, when seawater temperatures drop below 12 degrees Celsius, the ideal threshold for seaweed to reach maximum thickness and nutrient density. However, the operation only truly scales up once the blades reach 15 to 20 centimeters in length. This is the golden size that allows mechanical harvesting systems to precisely trim the upper portion without damaging the root structure, ensuring that every 15 days a new crop is ready to regenerate. Specialized vessels equipped with drum harvesters over 1 meter in diameter head offshore. These massive rotating drums function like giant wheels, rolling along cultivation lines and lifting dozens of meters of biomass out of the water at once. Here, high-speed circular cutting blades, spinning at thousands of revolutions per minute, sweep across the nets like an industrial clipper, shaving only the upper fronds while leaving exactly 5 centimeters of the base firmly anchored to the substrate. The entire process is powered by a fully hydraulic system. The moment the seaweed leaves the cutting blades, high-capacity suction hoses pull the cascading biomass directly into pre-washed tanks. Immediately afterward, mechanical compression systems squeeze out excess water before the seaweed is packed into specialized mesh bags weighing up to 800 kilograms each. Finally, onboard cranes hoist these massive bags onto barges for overnight transport back to shore. This closed-loop operation allows tens of tons of seaweed to be processed within just a few hours, locking in biological freshness before the first light of dawn. If net-based cultivation forms the backbone of Asia's seaweed industry, then on the other side of the globe, the North Atlantic relies on a very different resource: vast, natural kelp forests, anchored to rocky coastal seabeds, where biomass density can reach 20-30 kilograms of fresh seaweed per square meter during peak season. During the harvesting season, small to mid-sized fishing vessels approach mature kelp beds near shore. Crews haul massive kelp fronds directly onto the deck by hand or with low-power mechanical winches, then selectively cut approximately 60 to 70% of the blade length, leaving the holdfast and basal stem firmly attached to the seabed. With this method, kelp forests can regenerate almost completely within just 3 to 5 months, depending on water conditions and light availability. On deck, the seaweed is cleaned and roughly sorted, then bundled and transported back to shore the same day. This steady flow of raw material supplies dietary supplements, animal feed, and organic fertilizers, where biological renewability is valued more highly than short-term yield. Unlike industrialized models, this harvesting approach treats seaweed as a living component of the marine ecosystem, extracting just enough to allow the ocean time to recover, rather than pushing it to exhaustion. At the opposite end of the spectrum lies a far more meticulous approach. Hand harvesting remains the gold standard in regions with rugged coastlines or within strictly protected marine areas, such as Brittany or Connemara. Only during extreme low tide can harvesters access the exposed rock shelves, where they carefully cut individual blades of kelp or dulse using scissors or small knives. What defines this method is absolute selectivity. Only seaweed leaves meeting the highest standards of cleanliness and bioactive compound concentration are taken. It is this painstaking precision that elevates the harvest into a premium raw material, reserved exclusively for luxury cosmetics and high-grade pharmaceutical extracts, sectors where cellular purity is valued far above sheer volume. But harvesting is only the first half of the journey. In South Korea, the true value of seaweed is only unlocked once it enters a closed-loop processing transformation, where every variable, from moisture levels to cellular structure, is tightly controlled. The journey of a single gim sheet is, in essence, a race against time. The moment the seaweed leaves the ocean, the raw material must be processed immediately to lock in freshness and suppress enzymes that would otherwise degrade quality. Inside the factory, the cleaning process takes place in massive intake tanks, where water temperatures are kept below 10 Celsius to prevent the onset of decomposition. Instead of using high-pressure water jets that could damage the delicate blades, the system relies on vertical axis agitators to generate slow, controlled vortex flows, preserving the integrity of the seaweed's fibrous structure. At the same time, millions of fine air bubbles released from the bottom of the tanks seep into every fold of the leaves, gently dislodging sand, sediment, and attached organisms, impurities that often hide within microscopic crevices, using buoyant force and the natural circulation of rising air. After cleaning, the seaweed is fed into high-speed cutting machines, where it is shredded into fine strands measuring 2 to 5 millimeters in length. This size is a deliberate technical calculation, small enough to ensure even dispersion, yet structurally intact enough to allow the fibers to interlock. The entire operation is carried out in a fully closed system, maximizing nutrient retention while preventing oxidation from ambient air. The mixture then moves immediately into slow agitation conditioning tanks for 20 to 40 minutes, where the seaweed is rehydrated and its polysaccharides are released. Gentle paddles maintain a continuous, low shear flow, producing a stable suspension with consistent viscosity. As a result, the seaweed fibers remain evenly distributed and ready for sheet forming without clumping. At this stage, the seaweed's first recognizable form officially emerges through a critical shaping process. The seaweed is blended with water at a precisely calibrated ratio, after which metered pumping systems spread the mixture onto moving mesh molds. Low-pressure spray nozzles, programmed with exacting precision, distribute the slurry so that every square centimeter of the mesh receives the same amount of material. This is the moment when a gim sheet takes on its initial structure, demanding extreme uniformity to prevent rippling or warping once moisture is removed. Next, the seaweed enters a multi-stage drying chamber, a long tunnel system divided into strictly controlled temperature zones ranging from 40 to 60 degrees Celsius. Rather than using high heat for rapid dehydration, the factory relies on high-capacity recirculating warm airflow to draw out moisture gradually. Controlled drying process is the key to locking in the seaweed's signature ocean aroma and preserving its deep, glossy blue-black color, while also protecting heat-sensitive vitamins, such as vitamins A and C, from degradation. At this stage, the sheets are not yet released for consumption. Instead, they are stacked, aligned, and bundled into temporary batches. These bundles of dried seaweed are sealed in moisture-resistant packaging, allowing for short-term storage and internal transport, without altering the sheet's color or their inherent biological crispness. The gim then moves directly into a fully automated precision seasoning line. The sheets travel along a low-speed roller conveyor, ensuring uniform surface exposure to a network of low-pressure micro-spray nozzles. Here, a thin layer of refined vegetable oil, most commonly sesame oil or neutral vegetable oils, is applied with tightly controlled dosing at 1.5 grams of oil per 100 grams of dried seaweed. In parallel, fine salt and signature seasoning blends such as mustard, wasabi, or proprietary formulations are evenly dispersed, keeping flavor variation between sheets below 5%. After seasoning, the gim enters a second roasting chamber, where exposure time is shorter, approximately 30 seconds, while the temperature is precisely calibrated at around 180 degrees Celsius. The purpose of this final roast is to lock in seasoning aromas, evaporate excess oil, and create a uniformly dry, crisp surface, the defining factor behind the clean, audible snap that characterizes premium-grade gim. Once the gim reaches a fully dry, crisp state and is evenly infused with seasoning, the automated packaging line is activated. Robotic pick-and-place arms, operating at speeds of over 100 units per minute, swiftly transfer each stack of sheets into plastic containers according to pre-programmed portion specifications. Before the process is completed, a specialized desiccant packet is placed at the base of each container. The package is then sealed with a heat-bonded film using infrared sealing technology, completely isolating the contents from ambient moisture and preserving the product's signature crispness with absolute consistency. Now, let's step into the kitchen, where one of the most iconic dishes made from seaweed comes to life: sushi. On the work surface, a layer of still-warm rice is spread evenly over a sheet of dried nori, which is maintained at 7 to 8% moisture content before use. The filling is placed neatly at the center, and everything is hand-rolled with controlled pressure, just enough for the seaweed to wrap tightly around the rice without breaking its structure. The nori begins to absorb moisture from the rice, shifting from crisp to pliable and locking the filling firmly inside. At this moment, the seaweed releases a subtle ocean aroma and deep umami notes, blending with the softness of the rice and the natural sweetness of the fish. Beyond sushi, another iconic dish made from seaweed is seaweed soup. The cooking process begins by soaking dried seaweed in cool water to rehydrate it, allowing the strands to expand and regain their natural structure. After being rinsed and trimmed, the seaweed is briefly sautéed with sesame oil, then simmered with water or broth at a moderate temperature for a short period. During cooking, the seaweed releases essential minerals and bioactive compounds directly into the soup, including iodine, calcium, iron, and soluble polysaccharides. Because the soup is not cooked for long, many heat-sensitive micronutrients are preserved. As a result, seaweed soup is considered a nutrient-dense yet light dish, commonly consumed to replenish minerals, support metabolic balance, and aid recovery in everyday meals. Every August, when salmon fishing season reaches its peak, the waters off Nolesen come alive. Fishing fleets line up, slicing through the waves in search of what many call the silver treasure of the sea. When the radar detects a school of salmon beneath the icy surface, the crew springs into action, deploying massive nets that form a wide arc, slowly tightening to trap the entire shoal in a giant pocket. A single haul can bring in up to 20 tons of salmon, nearly 40,000 fish thrashing in the morning light, spraying water across the deck like a shimmering storm. The ship vibrates with life, rumbling engines, rushing water, shouting crew, all blending into a floating factory at sea. To preserve freshness, the fish are immediately transferred to chilling holds kept near 0 degrees Celsius, slowing biological breakdown and locking in texture and color for hours at sea. Once ashore, these silvery harvests continue their journey to cutting-edge processing plants. For top-grade salmon, destined for sashimi, worth tens of thousands of dollars per ton, the journey may take to the skies. Some shipments fly direct from Norway to Tokyo within 36 hours, arriving just in time to please even the most demanding sushi connoisseurs. However, Faced with an increasingly brutal journey of survival, salmon have gradually been guided by humans into farms, through artificial waterways engineered to replace the wild. Each spawning season, they leave the ocean and swim thousands of kilometers upstream to return to the very river where they were born. They battle fierce currents, leap over roaring waterfalls, all to complete their life cycle. But nature has never been gentle on this journey. As they leap up waterfalls, they often come face to face with the infamous brown bears, patient predators lurking at the base, waiting to strike the moment a fish breaks the water's surface. Those that survive it all, the female digs a nest in the cold gravel, the male fertilizes the eggs, and both die in exhaustion. Though each fish can lay thousands of eggs, nature is unforgiving. Only about 1 in 1,000 offspring survive, grow, and are lucky enough to return to the sea and continue the cycle. That's why humans have created an alternative path, where nature is recreated through high technology. In freshwater zones near estuaries, dams and artificial fish ladders not only help the salmon bypass obstacles, but also serve as checkpoints for health and behavioral monitoring. The strongest fish are selected and transferred to specialized tanks, where every condition, from temperature and oxygen to water flow, is precisely controlled, preparing them for the most crucial phase, the collection of eggs and milk, launching a new life cycle under human guidance. In the wild, salmon fertilization is a fierce battle among males, a tense showdown where only the strongest wins. But in fish farms, the process is far more gentle. The only thing the salmon have lost is the chance to choose their own mate. The female is placed on a processing table, where a gentle incision reveals rows of plump, amber-colored eggs, neatly aligned like strands of deep-sea pearls. Depending on the species and size, each fish carries between 2,000 and 10,000 eggs. At the same time, the males are handled with care to extract their milk. Within just 30 to 60 seconds after the eggs are harvested, the sperm must be mixed immediately in a clean, clear tray, free from blood or impurities, as even a single drop can ruin an entire batch. If delayed, the eggs will dry out and lose their ability to be fertilized. While in nature, less than 1% of fertilized salmon eggs survive, in the controlled environment of a hatchery, that success rate can reach up to 90%. The fertilized eggs are immediately transferred into specialized incubation trays, placed within a flowing water system that gently mimics the cool, clear streams where salmon were once born. The water temperature is carefully maintained between 10 to 12 degrees Celsius, refreshingly cold and crystal clear, just enough to awaken the dormant spark of life within each fragile shell. After about 2 weeks, tiny eyes begin to appear inside the eggs, a subtle yet miraculous sign that life is slowly awakening. Around day 45 to 60, the young salmon break free from their shells, entering the sac fry stage, carrying a yolk sac under their belly that sustains them through their first few weeks without the need for food. Once the yolk is absorbed, they transition into the fry stage, where they begin swimming, feeding, and adapting to the flow of water. They are then moved to larger rearing tanks, where every environmental factor is carefully controlled. When they reach about 5 centimeters in length, they're known as fingerlings, still small, but already bearing the shape of mature salmon. At this stage, the process of saltwater acclimation begins. Salt is gradually added to the water, like a gentle reminder of the vast ocean that awaits them. As young salmon grow and begin to take on the distinct shape of a migratory fish, they are moved to brackish water areas near river mouths, a natural transitional environment where fresh water mixes with saltwater, helping them adapt more easily. Salmon are such voracious eaters that they almost never turn down a meal. Their daily diet consists of compact, nutrient-rich pellets, made from fish meal, fish oil, soy, and various minerals. Each pellet is packed with everything the fish need to grow quickly and develop that signature reddish-orange flesh. On average, each salmon pen consumes around 2 tons of feed per day. Notably, feed accounts for 50 to 70% of the total cost of salmon farming, making portion control a critical factor for every farm. Even a small miscalculation in daily feed allocation can result in financial discrepancies of tens of thousands of dollars each month. Unlike wild salmon harvesting, which depends on migration seasons and open sea fishing, farmed salmon can be harvested in a much more controlled and proactive manner. Once they reach the ideal weight, typically between 4 and 5 kilograms, the fish are guided into an automated grading system to check their size and health condition. Qualified individuals are then pumped directly onto harvesting boats or transferred to onshore processing facilities. The entire process follows a fixed schedule, ensuring a stable, year-round supply without relying on nature's timing. And now, let's step inside the processing plant, the moment we've all been waiting for, where thousands of fully grown salmon are turned into premium food products. Before being filleted, female salmon are carefully examined to harvest their eggs, a key ingredient used in the production of premium caviar. After being extracted from the fish, the roe is transferred to a specialized washing system to remove blood, membranes, and impurities. Ultra-fine spray nozzles gently clean off the outer mucus without damaging the delicate membrane of each egg. The salmon roe is then transferred to brining tanks, where a salt solution is gently stirred by soft paddles in a steady circular motion, allowing the salt to evenly penetrate each egg. Salinity, temperature, and timing are strictly controlled to firm up the eggs, bring out a beautiful amber hue, and preserve their naturally rich, briny flavor. Once brining is complete, the roe moves to the final inspection station, where bright white lighting helps technicians detect any broken, cloudy, or underperforming eggs. The final product, shimmering, salted pearls, is portioned into specialized tins by automated dosing machines, packed precisely in 200 or 500 grams. Then the tins are chilled and neatly stored, ready to deliver a taste of the ocean to dining tables around the world. And the journey still doesn't end there. Entering the filleting stage, the pinnacle of salmon processing, each fully grown fish is passed through a modern fillet machine. High-speed rotating blades simultaneously remove the backbone and split the fish into two symmetrical halves, all while preserving the freshness and integrity of each muscle fiber. For smoked salmon products, the skin is intentionally kept, acting as a natural shield for the meat in the steps that follow. Next, an automatic bone removal system takes over, using ultra-precise clamps to extract any remaining pin bones. The fillets are then scanned by optical sensors that assess color, freshness, and texture. Any pieces that don't meet the standards are instantly removed from the line. Yet few people realize that the vibrant orange color often seen isn't natural. Freshly caught salmon usually has pale pink or deep red flesh. To achieve that eye-catching hue, many factories use carbon monoxide gas, an industrial makeup that keeps the fish looking fresh long after processing. So the real question is, how can you tell if a piece of salmon is truly fresh and not just fresh-looking? At this stage, the salmon is ready to enter the smoking line, the final step where raw fish is transformed into one of the most refined delicacies ever crafted from the ocean. It all begins with salting, a process that may seem simple, yet plays a decisive role in shaping the final flavor. There are two common methods: dry curing, where fine salt is evenly sprinkled over the surface of the fish, allowing its natural moisture to draw the salt inward, and wet brining, where the fillets are soaked in a saltwater solution, typically containing 3 to 5% salt, depending on the desired curing time. Both techniques aim for the same result: to reduce moisture, enhance the natural saltiness, and build a flavorful foundation for smoke to cling to and penetrate deep into the flesh. Once ready, the fish is placed on trays or hung on metal racks inside the smokehouse. Oak, maple, or cherry wood is gently smoldered, releasing thin, warm streams of smoke that weave through each fillet, infusing it with the subtle aroma of both wood and thyme. Depending on the intended product, smoking can last anywhere from 4 hours for a lighter flavor to 24 hours for a richer, deeper profile. With smoked salmon, time is the secret seasoning. A slow and deliberate process where technique, ingredients, and human intuition blend together to create a dish that carries not just flavor, but traces of fire, smoke, and memory. When the smoking process comes to an end, the salmon has fully absorbed the essence of fire and wood, ready to enter its final stage: packaging. Each slice is placed into a vacuum sealing system, where all air is removed to preserve its moisture, texture, and the delicate smokiness that has gently permeated the flesh. From chilly processing facilities in the far north, smoked salmon begins its journey, traveling thousands of kilometers to reach dining tables in Tokyo, Paris, or New York. It's more than just food. It's a culinary voyage, carrying with it the essence of the sea, the warmth of wood smoke, and the craftsmanship of human hands.